A dynamic encephalopathy means that it's not fixed, it can change, like the people who pop out and then go back in. So this is not a fixed, static one, it's dynamic. And if you have, and this is something where I feel really sad in my profession of child neurology. People feel triumphant when they identify the gene, and they think that explains everything about that person. It doesn't. You can still work with things that modulate that encephalopathy, that can make someone feel substantially better or worse. People with genetic syndromes who have gut issues can benefit from having a better diet, and they can have better function, better sleep, and so forth. Interestingly, the Huntington's disease gene was identified at Mass General, and 13 years later, I remember this was about in the late 90s, there was a front page story in the Boston Globe. The Huntington's gene has been identified, but no treatments have resulted. But what they said in the article was that there was one drug that people were using, and it was slowing the degeneration in Huntington's and having people have a longer period of time where they felt less bad. What was that drug? It was minocycline. So what is minocycline? This is an antibiotic that's not used that much as an antibiotic, but it happens to inhibit microglial activation. It inhibits inflammation. And there is, or was, I don't know the current status of it, a minocycline trial for autism going on at the National Institute of Mental Health because of the inflammation. So that's a treatment that's based on the idea that if you treat an active process that's actively going on in your brain, you can make a difference. That's what steroids do. They take down the active inflammation. They're not changing your wiring down here. They're taking down stuff that's going on right now. So you can actually do things that help people. By the way, one of the things I forgot to say about genes is people say that, let's say, Fragile X causes autism. First of all, only maybe 30%, the figure is somewhere between 20 and 50% of people with Fragile X have autism. So if Fragile X causes autism, what about the other 50 to 80% who don't have autism? I think the way to think about it really irritates me when people say that a gene causes autism. To me, what makes more sense is genes increase your risk so that if you have something coming along that increases the excitation or reduces it, you're already halfway there from the gene. But how severe you get, or even whether you get over the edge of having a problem, has to do with all the other stuff that's piled on top of it, and how much stuff you need to pile on top of it. I think there are probably a few genes that are more or less enough. But for the most part, they're going to need to get a whole lot of help from things that you actually can do something about and maybe even prevent. So the paper that I have that diagram in has a title. It's in a book by Amy Zimmerman, and I have the closing chapter. And it's expanding the mechanisms of autism. So it's developmental, but it's also chronic. It's behavioral, but it's also physical. It's genetic, but it's also environmental. It's brain and nervous system, but it's also systemic. And when I say behavior and physical, I also mean medical. And when people think it's lifelong and static, actually change and improvement are possible. So I think, what do we do now? From the broad perspective, we need to give biology a much bigger place in the autism agenda. That's starting to happen, but people are still, they're not quite clear what kind of biology, but it's changing. You have to realize that autism has a lot of company with other chronic illnesses with similar underlying mechanisms. A lot of the stuff we're talking about here is completely not unique to autism. I think it's the combination and when it happens, which is probably what creates the autism, not any one specific thing that's uniquely autistic. Recognize and realize that practical day-to-day things may be what may be of some help, such as diet. Embrace the heterogeneity, not assume that everybody's the same. Learn from what we do now and what we observe now. And do research and practice as if this is a real public health crisis and environmental emergency. Okay, this is just a quick thing. A researcher who used to be at Columbia looked at people, 1.5 million medical records in Columbia, and if you had like autism or bipolar schizophrenia, what else did you have? This is the the list of the stuff that he came up with for autism. A whole lot of, psychiatric, bacterial, allergic, cancer. Again, my friend Mark Corrales, the guy who searches the literature, he went through, got the top 9 of these things, dug up the genes that were associated with them in the literature, and found that among the top 9 things associated with autism, the genes for each one of them overlapped hugely with each other, and that a huge number of them were immune-related genes. So this supports my argument that it's not really that specific what we're talking about. To summarize the medical part in a schematic way, I've explained to you that genes can mess up your excitation inhibition ratio, toxics can, infection can, and over here you've got the excitation, the sensory and sleep problems, and the HPA, that should say stress, hypothalamic pituitary axis. So genes modulate vulnerability to toxics and infectious stress. Toxics impair immunity, and infectious and immune stress alter gene expression. So that's this circle. Here, you've got increased excitation contributes to sensory overload and sleep destruction. This makes you more stressed out, and this stress then makes you have worse. So it's a vicious circle, worse excitation. So genes, this is the same thing. Genes do the excitation inhibition, toxics do the excitation inhibition, infections louse that up. So these are 3 things that you can do something about, except for the genes. 2 things. Stress makes you more vulnerable to infection. Stress changes your gene expression. These are all well known. What you can do, reduce toxic exposures, detox, reduce infection, reduce stress, it'll make you less vulnerable to infection, and it will help you have healthier gene expression. Then you're left with the genes. But look at all the overlay that you've taken away from there. A lot. So what I've been doing is working on what I spend my time doing is, one of them is I'm working with the Autism Society building a database to capture information in a model that, in order to challenge this and also to help people individually at the same time. And also working at a research level on measuring things that would really help us. Because I think most of autism researchers are measuring what's wrong, but not how we can move things. So I have my Transcend Research Program. That's a program, it means treatment research and neuroscience evaluation of neurodevelopmental disorders, and that's our logo. And we're doing brain imaging really to look at what's going on to make the brain big. How much do the sensory issues have to do with the tissue issues? Are they related to each other? And how much are we doing, and how much is the body related? And then this informatics platform. So we're looking at brain enlargement, what the tissue properties are, as I showed you. I have my colleague Tal Kennett is doing MEG researches to see how this excitable brain processes sensory. And our theory is that if it's really the tissue underlying it that does that, then the brainwave changes should be similar in auditory and in sense and visual and in tactile sensory, somatosensory. And that would suggest that the problem is not something that goes after a specific sensory area, but something that's going after the cells that drive the sensory. We're doing metabolism and brain processing. I have a new SIP study going, which I think, yeah, I do have a slide. I want to tell you about that. Metabolism, brain, body in infants, and I'm building a study to study change from treatment.